So in previous class we were discussing key value data store, that is simplest form of the NoSQL database, and we discussed there are only three operations which are supported by this key value data store: to keep data in the data store, to retrieve, and to delete. There is one important factor that is called consistent hashing, and we have suppose very large number of key value data, and we have to store them on several different nodes, okay, or several different storage devices, and we want that our data should be stored uniformly or in some balanced way, so that each node have equal amount or equal data in capacity, and how it can be done automated. So one solution is this consistent hashing that we will discuss, and the second we will discuss how relational data can be converted into key value data. Okay, two things we will discuss today. So hashing, you know already, hash function. We have some value, and when we apply hash function we get a smaller size value set, or we get values only a limited range. So with the help of hash function, for very large number of values we can make one index small table, and for this purpose we make a function that we call hash function. So hash function converts a given number of a smaller number. Hash function converts a given number to a smaller number and uses a small number as index in a table called hash table. Okay. So in practice, suppose this is the key value data, and if we apply hash function and we make that hash values, they are 1 2 3 like, and suppose I have 5 data store or 5 nodes, and based on values generated by hash function 1 2 3 4 5, the values key based on the key value, the hash values are generated, and the data values can be stored in this form. But suppose what will happen if one node is removed from this cluster? The problem may be that we have to reassign all the data values, because now a hash function is changed, or the values that were earlier being generated by hash function, now it has lesser number for hash function that was earlier generated. So how this problem can be resolved? So that technique is simple technique, and it is called consistent hashing. So before coming to the actual explanation of this consistent hashing, we have one small experiment that will help us to understand this consistent hashing. So suppose keys and nodes are placed on a ring for distributing data on different nodes. Okay, so this is the ring, and here we compute position on ring using the following hash function. Okay, so on this ring we have because it is circle shape, so we can also imagine in form of 360 degree from center. So if any position on this circumference on this ring we have to identify, one argument can be in terms of angle. So 0 degree, 1 degree, 2 degree, 90, 180, 270, like that. So they can also be used for referring the position on this ring. So this is the to identify, to make any position on ring, this function is used as key mod by 360. So we choose 360 for representing the things on circle, as the circle has 360 degree. So now what we shall do, we keep node on the ring, and then we will apply hash function on the data key, and it will generate the value, hash value, and that value may be kept on one of the nodes, and on this node we have to keep that data value. We will make some rule. So you see here, suppose there are 3 nodes, keep 3 nodes A, B, C at position 120, 240, 360 or 0 degree. This red color they are representing. A is 120, 240 and 360 on ring. We can keep them at any place. Just for convenience, I have taken 120 and 240, but you can keep anywhere. Okay, later on we will come to know. So hash values of individual node here will be like 120 mod 360, 120 240 mod. So these values will be, so they are the positions on this ring. Find hash values of keys and place them on the ring according to the hash values. So this is node A, node B, node C, and they are the key of my data values. Okay, so these key basically the 1, 2, 3 I have written for convenience, so we are considering they are the actual value that will be hashed. So after hashing we get some value here, and that value is corresponding to position on ring also, because we have taken 360 mod. So this mod 360 30. Similarly, when we divide by 360 modular arithmetic, so we will get all these values. Okay, so 3093 mod 360, it will come out 30. So 30 will be placed here. Okay, so this is written 1. Second 2960, it is at 80 degrees, so this is 2. This is key 3, 150, then 200, 263, key 4, key 5 and 6 key, they have been kept here. Now we make rule that when we move on circle in anti-clockwise, and whatever node comes, we assign these key to that node. Okay, now map each key with the node which is closest to it in counterclockwise. So suppose 6 key. Now we will keep, or we will store these key on which node. So I make that we move in counterclockwise, and whenever new first node appears to it, it will be stored. So you see, when we move counterclockwise from here, key 1, key 2 will be mapped to A. After 1 and 2 we come A. Then key 3, key 4, then we have here, so key 4, key 3 and key 4 will be mapped to B. It is written here in B, it is in A, and this 5th and 6th key at angle to 6320, they will be mapped to C. Okay, it is also written in bracket. Okay, so 6 key here, there will be very large number of key in practice. So they have been mapped to these node A, B, C according to this rule. Now map each key with the node which is closest to it in count and counter or anti-clockwise direction. Here this instead of anti-clockwise clockwise rule can also be made. Okay, so there is no need, it is not necessary always you go for counterclock. If the position of the node and key is same, then assign the key to the node. This is a rule. So this is the experimental setup. Now we add a node in cluster. Okay, you can also assume this is a cluster. So we add a new node in cluster and we check whether the key that were earlier assigned have disturbed and how they cannot be made so that reassignment curve should be minimal. So case 1, add a node. Suppose we add a new node D. Okay, so you see here this is new node D at 90 degree. It is shown here, red color D. So suppose we add a new node D at position 90 on the ring. You can add anywhere. Okay, so we can add anywhere on the ring. Only those keys will be redistributed whose values lie between D and C. D and C. Now they will not point to A. They will point to what? You see here when we add this new node. So, and earlier our rule was the keys will be assigned to that node which are close to it when we move anti-clockwise or counterclockwise. So you see here D is added. So you see the first key and the second key, now they will be assigned to D. Earlier first and second were being assigned to A in this experiment, 1 and 2 A. Now 1 and 2 they are close to D, so they will be reassigned to D. So only these two keys are disturbed here. Rest key will remain as such. Okay, 1 and 2 will be reassigned to D instead of A now. So this change we have to make here. And here you see the new position, what happens here. Node A, node B, node C, node D, they are the angle and position shown here. Key values. Okay, so now this first and second will be assigned to D. Okay, I have not written, but I should write it here. Second, if we remove a node, then what will happen? Suppose we remove a node C from the ring. Earlier here we have this C node and now we are going to remove it. So this is the picture, and A and B are still present. Suppose we remove a node C from the ring. Only those keys will be redistributed whose values lie between C and B. Now you see when we have removed, so what will happen? Earlier the C is removed, so this 1 and 2 were assigned to A. Now this is removed, so 5 and 6, these two keys will be assigned to A in place of C now. So you see here, so now they will point to C. So point key 5 and 6 will be reassigned. This key 5 and key 6 will be reassigned. Okay, and they will be assigned now to A. It is written now they will not point to C, they will point towards A. So rest other redistribution will not be going to be affected. Only this set of key will have to be changed, or the keys falling in this range. So this is node ABC, and we have removed this C. So this is the new position on ring of nodes, and here actually I should also show here the nodes, new nodes, here it is assigned. Okay, so this is how consistent hashing solves the rehashing problem. The number of keys which needs to be redistributed after rehashing is minimized, so less number of memory fetches, hence performance is optimized. This was the same explanation we were discussing in previous class, but it was written somewhat more text form, and but now we can easily understand that. Consistent hashing for distributing key value pairs. A variation of data distribution algorithm known as consistent hashing is used in Voldemort for data distribution among the nodes in the distributed cluster of nodes. We have distributed cluster, we have several nodes here, and we want to distribute key value data among them. So one algorithm has been designed, and this is called consistent hashing. So it is nothing, it is a variation of data distribution algorithm. Roughly we can say it is a data distribution algorithm, but has some feature and ability. So as consistent hashing is used in Voldemort, this algorithm has been used in this key value database, that was DynamoDB. This is proprietary of Amazon, and this is open source Voldemort. Okay, so for understanding that DynamoDB we do not have details, but this open source, it is the same. So a hash function hk is applied to the key k of each kv pair, okay, key value pair, and hk determines where the item will be stored. Hash function, we identify the position where we have to store. The method assumes that hk is an integer value, usually in a range of 0 to h max, some value that is to be power of 2. So this is the range where we have to generate the value. The value will be generated by the hash function, where n is chosen based on the desired range for the hash values. Okay. The method is best visualized by considering the range of all possible integer hash values 0 to h max to be evenly distributed on circle or ring. The nodes in the distributed system are then also located on the same ring. Okay. Usually each node will have several locations on the ring. The positioning of the points on the ring that represent the nodes is done in a pseudo-random manner. Pseudo-random means random. Basically, how do we define random? Random is natural phenomena. Nobody can predict it. But if we have to develop some kind of a similar kind of some values that we have randomness in nature, but those values are being generated by computer using some algorithm. So somebody can argue that it is not true random, it is pseudo random. So pseudo random word is used in practice. So the positioning of the points on the ring that represent the nodes is done in a pseudo random manner. An item kv will be stored on the node whose position in the ring follows the position of hk on the ring in a clockwise direction. Here clockwise is written, so there is no question clockwise, anti-clockwise. So any convention can be used. So in this figure we assume there are three nodes in the distributed cluster labeled ABC, where node C has a bigger capacity than node A and B. So in a typical system there will be many more nodes on the circle. Two instances of A and B are placed. Here A and B are two nodes and they are replication or instances. Instances means they are also a node. Okay, copy of. So A and B, they have been copied. Actually, copy, not exactly saying copy, it is another node. Okay, but for software it is and for hardware two issues comes here. So logically it is same, but physically it is different. This is correct explanation logically. Or it is instance of, somebody can argue it is a type node. Okay, so we assume there are three nodes in the distributed cluster labeled A, B, C, where C has a bigger capacity than node A and B. In a typical system, there will be many more nodes on the circle. Two instances of each A and B are placed and three instances C, because it is higher capacity. So in a pseudo-random manner, to cover the circle, figure A indicates which KV items are placed in which node based on the H key value. You see here this is A, B, C, and here you see this is C, this is B, this is another C. So three copies of C are here and two copies of B are present here. When we say A node, we correspondingly define the range of values. If key is falling in this range, then they will go or they will be stored on this node. So this is shown here, range 1 to node A, range 2 to node B, range 3 to node C, like this explanation. So here you see here, similarly for node A, range 1 is shown here. So similarly some other place node A is present, then there will be range 1. Here it is range 1. So if keys are falling, then they will go to this node. Okay, so, and this is situation when node is added. So we will discuss this diagram later. The HK values that fall in the parts of the circle marked as range 1 in the figure A will have their key value items stored in the node A. Okay, because that is the node whose level follows HK on the ring in the clockwise direction. Those in range 2 are stored in node B, and those in range 3 are stored in node C. Okay, so range 1 key, range 2 key, range 2 keys and range 3 keys, they are stored at node A, B and C. This scheme also called horizontal scaling, because when a new node is added to distributed system, it can be added in one or more location on the ring depending on the node capacity. Only a limited percentage of KV items will be reassigned to the new node from the existing nodes based on the consistent hashing placement algorithm. Also, those items assigned to the new node may not all come from only one of the existing nodes, because the new node can have multiple locations on the ring. For example, node D is added and it has two placement on ring as shown in figure B. Okay, now D node has been added and it is added at two places. This is D node, you see here, and this is another D node. Okay, it is between A and B here. Okay, so this is D node here, and we see so for example, if D node is added two placements on the ring as shown figure B, then some of the items from node B and C would be moved to D. So what will happen when we add here, then few items of it is saying B. So you see here, if we make rule then to go clockwise direction and anti-clockwise. So one explanation here is wrong in this book. So you see here, if we make rule of clockwise direction, then what will happen? A key data of A will be this D added here. So just a minute, first I read, then I will come here. D added and it has two placement on the ring as shown this, then some of the items from node B and C would be moved to D. From B and C it is saying. So D is here and D is here. So it is saying some data from B will be moved here. So if we make rule when we go to clockwise, so as per the convention of clockwise, data of the item whose key has range 4 on circle C would be migrated to node D. Range 4, range 1, range 2. Now its range, when we add D, then it is the range 4. Okay, and this range B is this one. So some data from B to D will be moved. So when we say this, when we move this one, actually there is a mistake clockwise and anti-clockwise. So the explanation comes using clockwise here. So it is also written somewhere. I am coming here. So there is no confusion, clarity is there, but only some convention issue. So there is no problem. So don't be confused here. The item whose keys has range 4 on the circle would be migrated to D. This scheme also allowed replication by placing the number of specified replicas of the item of an item. Something I left. I start from here. For example, if node D is added and it has two placements on the ring as shown in figure B, then some of the items from node B and C would be moved to D, B and C. So these item range C reduced, and it is written here C. This will move, the item will be moved only when if we move in anti-clockwise. Okay. Similarly here, this B item will be moved to D if we make rule of anti-clockwise. Okay. Data which is close to the node, when we move anti-clockwise, then B, this C data will be moved to C to D, B and C, from B and C. So from C here and from B here, okay, it will be only when we have anti-clockwise. Okay, but here they have taken clockwise, so that is some, I think, mistake maybe, but understanding issue, there is no problem. Migrated to node D. This scheme also allows replication by placing the number of specified replicas of an item on successive nodes on the ring in clockwise direction. Okay. So the sharding is built. Sharding means dividing data on several nodes. So how sharding is done? So this is technique. The sharding is built into the method, and different items in the stored file are located on different nodes in the distributed cluster, which means the items are horizontally partitioned or sharded or distributed among the nodes in the distributed system. In this way, we have very large volume of data, and the process of distribution have to be made. So in this is the method how we can go ahead. When a node fails, okay, its load of data item can be distributed to the other existing node whose level follow the levels of the failed node in the ring. Okay, so you see here instance of T, instance of B. So one is going to fail, then the same named data, named node can be used in the ring, and nodes which with higher capacity can have more locations on the ring, as illustrated by C. Okay, thus store items than the smaller capacity nodes. In consistent hashing is a special kind of hashing technique such that when hash table is resized, here when we add or remove node, so basically hash size is going to be changed, right? But the inconsistent hashing, when node is added or removed, the reassigning remains unaffected, or if it is going to be affected, then only a limited number of items have to be reassigned. Resized only. Key need to be remapped on average, where is the number of keys and the number of slots. In contrast, most traditional hash tables, a change in the number of array slot causes nearly all keys to be remapped. So now we come, it is very simple how relational data can be converted into key value data. So method is straightforward. Suppose this is one student relation or table, and it has two tuples, student ID, key, student first name, and student phone number. The above student relation is represented key value database like student, this is this key value, and first name. Okay, second this key value and this phone number. Similarly, second record can be represented Okay. Now if we show relation, so this is complete key. You see, this is complete key and this is only the value m. So complete key here has this table name and this student, this ID, and this, then this is the value, this on number value. So basically how we are identifying the values here. So this is the, and similarly this is another way you can also student table ID one more simple example. Convert the following relation employee into key value. Okay. Employee 100, employee name, this is the name, employee address, employee. So 3 record we have. So this was about key value data store.